All right, let's kick this off, folks. Welcome, everyone. My name is Kamish Pamaraju from Platform 9. We are now kicking off our webinar on implementing Kubernetes storage considerations. This is the fourth in our series of webinars on implementing Kubernetes in practical production situations. So welcome, wherever you may be. Good morning, good afternoon, good evening. Today we have a very interesting set of presenters and a great topic to talk about, storage. And as always, we go through the steps in the journey towards Kubernetes. And of course, this webinar is all about storage. And we have a demo also slated for for today's webinar. So we will kick off with the introductions to the presenters. As always, this is Zoom. I'm pretty sure most of you are familiar with. You can use the Q&A button at the bottom of your screen, or feel free to put in any question in your chat window. And we will do the journey to Kubernetes recap as you go into production, lots of steps to consider. And then we'll jump into a fireside chat with our guest today, presenter, and then we'll do a live demo, and then we'll do a Q&A. And as always, feel free to ask questions along the way. And if the question is relevant to the discussion at hand, I will bring it up and we'll have the presenters answer them live. Next slide. So we always have a drawing, a learning online Kubernetes course from our learning partner, LearnK8s. And we will announce the winner at the end of this webinar, as always. And feel free to sign up for the webinar series. There's always a giveaway for every session. Next slide. So let's get into the speakers and agenda for today's session. We have our CTO and head of solution engineering, Peter Frey. And he will introduce himself shortly, but he's been our mainstay for this webinar series with a lot of experience doing actual field implementations and production environments with our customers. I would also like to welcome our guest, Michael Ferranti, who is a senior director of product marketing at Portworx. As many of you know, Portworx is now part of Pure Storage. And we've had lots of great conversations and webinars with Michael in the past. So welcome, Michael. And we'll have a great fireside chat between Peter and Michael shortly at the middle of this webinar. Next slide. And we also have our product manager, Chris Jones. If you've been attending our webinars, he's been part of our webinar series. Brings a lot to the table, lots of experience with monitoring and application performance in the industry. So we're excited to have him today. He's going to give us a live storage demo with Portworx and Platform 9 working together. So with that, I'm going to hand it over to Peter, who's going to give us a quick tour of the journey towards production Kubernetes, and then we'll do the fireside chat right after that. Over to you, Peter.
Awesome. Thanks, Kamesh. Thanks for the introduction. Yep. Hi, everybody. My name is Peter Frey. I am the field CTO here at Platform 9 Systems. I've been here for about 3 years. I'm presenting to you today from sunny Florida, not warm Florida today, but sunny. And we'll start this off with, the attention behind the entire series here at Platform 9 to have this webinar was really the enterprises and people that I talk to, and I talk to people every single day that are looking to adopt Kubernetes. They're on this journey, right? And they're trying to figure out, what does Kubernetes mean to their business? How can we implement it? And what are kind of the phases that I'm seeing as a generalization that most of our customers or our enterprises are going through? And that's what this is about. And the webinar series is really designed around that. So as you're working to adopt Kubernetes, you're going to go through some of these steps. We already spoke about networking and networking sub webinar on 5G, but now we're at the storage one. So let's just jump right in. So I talk to enterprise architects. I talk to people in the office of the field of the CTO. I talk to developers. I talk to SREs. It doesn't matter. Almost every organization that I talk to today is trying to figure out, what does Kubernetes mean to our enterprise, right? Then they always start with, well, let's get a Kubernetes cluster and see what that looks like, right? And so then they start making decisions. Well, do I want to deploy this on the cloud? Do I want to use AWS or Google? Do I want to use on-prem infrastructure, VMs, bare metal, and what CNI should I use? And they start making these decisions, and they Google a lot, right? How do I do this and how do I do that? And then eventually they get a Kubernetes cluster up and running, and they're really excited about that, and they want to get that first application rolling. And everybody does this. I did it with my first Kubernetes cluster. We deploy a simple application, a stateless application that's, the Kubernetes Hello World app, or I did Nginx. I think that's the most popular one out there, just to see, hey, does this pod work? Does this thing run? And it does. And everybody's like, all right, moving on to the next step. And then they want to do something a little more complicated. And in my example, it was a WordPress application, right? Uh, and when I did this, it immediately failed. And I'm looking at the logs and trying to figure out why it failed. And it was something about persistent storage, the point of this whole webinar today. And I then like, well, how do you do persistent storage in a Kubernetes world? What is a PVC, and how do I define these different kinds of things? So I started Googling around that experience, right? I spent a day saying, all right, well, I want to get this WordPress thing up and running. I want to prove that it works. How do I do it? Do I want to use HostPath? Do I want to use any of the other CSI plugins? And we'll get into some of that here in a little bit. So I picked one, I deployed it, and I got my WordPress application up and running, and that was great, right? And then as I moved through my journey, and as enterprises move through their journey, they're doing different things, right? They told us, okay, we've got this first Kubernetes cluster, it's up and running, we've got an app running, we've got some persistent storage. How do we run one of our apps though? Let's pick one. And usually this is a tier D application. What I mean by a tier D application is it's not, my money generating application. It's not mission critical to the business. It's something that they've got, that's maybe an address lookup or something that's not, critical to their organization earning money. And if it goes down, they can tolerate some downtime. So they start looking at that application, right? That corporate application, and they start to figure out, is it containerized? If not, how do I containerize it, right? How do I Dockerize it, right? And they figure that out. If it is containerized, then they figure out how am I deploying it today? What's the difference between doing that and deploying inside of a Kubernetes cluster? And then they eventually get that up and running. A lot of kubectl commands, a lot of YAML files, that sort of stuff. And eventually they get it up and running. But then they start, well, if I'm going to really truly run this thing in production, how am I going to monitor that, right? And then this is right back to the Google machine. And so they start Googling around and they say, oh, there's Datadog. Well, that's expensive. Let's not go there. What else is there? Prometheus and Grafana. There's a whole bunch of other stuff, right? I just listed a couple here. Prometheus and Grafana is kind of the de facto standard for monitoring a Kubernetes cluster. So most of my customers that I talk to are actually evaluating that, or say, all right, let's start there. And then they look at tutorials and they figure out how to deploy it. And guess what? They need persistent storage again. So this thing keeps coming up. There's stateless applications and there's stateful applications, and my monitoring is going to require some persistent storage, right? So how do I do that? And then, so did I pick the right storage when I was playing around with WordPress? If I didn't, let's recreate this cluster, right? And pick a different storage that will fit for all my applications as well as my monitoring stuff. And so then maybe I'm cycling back and forth a little bit on this journey. Then, if we're monitoring and it's production and it's going out there, how are we going to do logging? How am I going to collect logs, right? And again, this requires persistent storage. Am I going to store them locally to the cluster? Am I going to have a separate logging server out there? Do I want to use something like Splunk? And you start asking all these questions about how I'm going to do logging in a Kubernetes world, because Kubernetes makes you think differently, right, on how to do just about everything. So, they Google, they find Loki, they find the ELK stack. I find most of our customers initially go down the ELK stack because, Elastic, Fluentbit, and Kibana, because that seems to be the most popular choice out there, and there's a lot of tutorials and it's easy to get up and running. But again, you need to have some form of persistent storage to make that work. So you've made a decision, you've Googled, you've deployed monitoring, you've deployed logging, and now you're starting to feel pretty good about this. And then you're starting to think, how do I repeatedly do this, right? Do I want to deploy, do I use CI/CD systems like Jenkins, X, or Spinnaker? Do I want to use my existing Jenkins deployment and adapt it to a Kubernetes cluster? All of that can be done. And that's what usually I see our customers doing, is they'll pick something they've already got, maybe it's a GitOps stack or something like that, and they will deploy a that adapted to Kubernetes and then start deploying their apps that way. So, but they want to be able to repeatedly deploy it, and that's very important. So it's a step that they come across in the journey. Then they start thinking, well, this is really cool. I can repeatedly deploy this thing. I can continuously deliver. I can do upgrades. I can do all this kind of stuff. It's running in Kubernetes. I'd really like to do A/B deployments. How do I do that? And then they start looking into service meshes, and then they start realizing that Kubernetes isn't just a tool. Oh, I go get Kubernetes and I have it in my organization. It's an ecosystem. It's Jenkins. It's Prometheus. It's Grafana. It's the EFK stack. It's the Linkerd and these kind of things. So they start googling on this, and they realize these are very big topics, right? They're not easy to implement always, right? And it has overhead, and I find that they push this step off sometimes to a later stage, but they start researching it so they understand what it's going to mean. But they want to get that application up and running as quickly as possible. So then at this point, we've got monitoring, we've got logging, we've got our delivery mechanism, and then information security gets involved, right? How are you going to do identity management on this production cluster? Who has access to this production cluster, right? Are you going to implement an OIDC system like DEX? You want to integrate with a SAML2 backend? How are you going to do that? I want to make sure that our SREs are the only team that can modify anything in the production namespaces, and development maybe can do it in different namespaces, or maybe it's probably even smarter to have a separate Kubernetes cluster for development and staging from our production environment. So these are the kind of decisions that information security is bringing into the adoption of Kubernetes, right? And then they're also starting to think about PCI. Is there any personal data in there, right? Credit card information, anything like that. Do we have red and green zones defined? How do I encrypt data at rest and data in flight? And all these different things when they're communicating different pods. It's all a little bit different than the way we've done it previously with VMs. So they eventually get through that, and they start to think we're ready. But then the SREs come in and they start thinking, well, how are we going to do day two operations on this, right? How do we do a Kubernetes upgrade? If I need to go from 117 to 118 to 119 of Kubernetes, how are we going to do that? What happens if etcd loses quorum? How do we recover from that? What happens if a master node disk fills up, right? How do we handle these different solutions, right? So they start asking stuff before they'll pass the gate of getting this app into production. How are you going to do that kind of stuff? And then at some point they get past that, and our customers experience their first production outage. And then they go down the path of really realizing how complex this environment is. There's a lot of great benefits for our Kubernetes in the enterprises, but again, it's an ecosystem. A lot of different things can go wrong. And we could talk about that at another time if everybody's interested, right? But what we're finding is the answer for most organizations is they want to have simple decisions across the board. They want to be able to deploy Kubernetes either as code through an API or through a user interface. They want something that they can say, you know what, just give me Prometheus, Grafana, and Alert Manager. Just give me the EFK stack and select that plugin and deploy it with the user interface. Same thing with our container storage interface, and we'll talk ad nauseum about that. But they also want simple decisions around the CNI. They want simple decisions around CI/CD, right? And they also want to be able to call somebody when there's a problem, right? Platform 9's got world-class support, right? We've got 17 or 18 certified Kubernetes administrators and more certified Kubernetes developers, right? And we've got an SLA around our product. It's a really awesome way to go. And we've got simple decisions for all of these boxes that you can see here. So moving on, this is the kind of the theme of that of the webinar series. We did the introduction, we did networking 1 and 2, and now we're at that storage phase. And we're just kind of mimicking the path that I just described as to how customers are going to start, adopting. All right, we've got my networking, I've got storage, and here's my options, right? And then we move from there. And in the future, we're going to cover logging, we're going to do some DevOps and CI/CD pipelining, upgrades and maintaining Kubernetes clusters, and then we're going to have a panel discussion at the end in April. I hope everybody can come back and join these as we continue on. but there's some great stuff coming up. The panel discussion will be experts from all of our previous webinars, and it'll be a Q&A discussion kind of event. So I'm very excited about that. I'll turn it over now to Michael Ferrante to talk about a little bit about storage with Kubernetes.
Yeah, thanks a lot, Peter. It's an emotional roller coaster, that journey to Kubernetes, and I think it absolutely echoes the experience that we see with customers. I think people pretty early on see the value, and then the question is, how do I get that for real, a substantial portion of my application, so that it's not just this one side project, but actually I can apply this idea of agile, on-demand, scalable deployments to my most important applications. And I think COVID really kind of was a line where customers who had started their Kubernetes journey and found that those architectures actually enabled them to kind of increase capacity by an order of magnitude pretty much overnight, really validated that move to Kubernetes. But there is a lot of complexity there. I think, and I may steal this from you if you don't mind, I could do a storage specific version of that, but I'll kind of summarize a little bit, and then we're going to talk about some of these themes in more detail during the fireside chat. We see that real enterprise adoption of Kubernetes. When I say real enterprise adoption, I mean using it for a significant portion of enterprise apps and applications that are important to your business. Really requires a Kubernetes native storage platform, the way that a managed Kubernetes service greatly facilitates or simplifies adoption of Kubernetes. And the reason for both of these is the platform has thought through a lot of these issues that you're going to run into that you don't necessarily think about until you've already run into the wall. So 3 reasons why a Kubernetes storage platform is really important part of your overall Kubernetes strategy is one, that all enterprise apps have data. So if we really want to apply this agile technology stack to our biggest business problems, that means some of those problems are going to come with storage and data management requirements. And if we don't have a platform that's customized or optimized for those problems, then we're going to have to kind of keep doing things the old way, which is the whole kind of point of moving to Kubernetes, which is to move past those manual processes. The second reason is that if you try to take your existing storage stack that was optimized and it runs very well for say your VMware apps or the apps that are running kind of traditional applications that are running in the cloud, then there's a mismatch between those environments, which are relatively static, and the scale and dynamism of a Kubernetes environment. And your functional testing isn't going to catch that when, for instance, you're provisioning 100 volumes all at once, or rescheduling a bunch of pods as part of an upgrade, and then your storage controller ends up choking on those multiple parallel operations, and you end up with downtime. Right? That's not the kind of thing that you can easily predict, but that is common in a day 2 scenario. And the third point is that kind of, as much as engineers, we try to decompose problems into their component parts and solve each component itself. There's been a tendency or a desire to say, let's take our storage and our databases, for instance, our queues or key value stores, and keep them outside of Kubernetes and keep using our existing tooling to manage them. But what ends up happening is you have this kind of bifurcated system where you have modern processes, DevOps, a CI/CD, agile development, microservices for one part of your application, but then it's all bound to traditional components or data services outside of the Kubernetes platform. And you're kind of only ever as agile as the least agile part of your application. So that in a nutshell is why you need to think about Kubernetes storage platforms as part of your Kubernetes strategy. The next slide, though, has a caveat for you, which is to say, you need to be aware, and can someone do the slides for me? Perfect. You need to be aware of kind of what I call seamless integration, which is Kubernetes, and Peter mentioned this, has a fantastic interface for talking between Kubernetes and your storage. It's called CSI. It stands for Container Storage Interface, and I'm sure we're going to talk a bunch about it in the fireside chat. What I want to point out, though, is that just because Kubernetes can speak to your storage does not mean the storage itself has any particular behavior. It doesn't mean that it's Kubernetes native. It doesn't mean that if I throw a highly dense set of volumes at it, many small volumes, and then I reschedule all of those volumes in a very short time frame as part of a migration, that the threading is going to keep up, that it doesn't have a single point of failure in terms of a controller bottleneck. Basically, just CSI isn't enough. You need to make sure that you're actually understanding the behaviors of your Kubernetes environment, and that your storage system can actually keep up with the scale and the dynamism of your environment. So if we go to the next slide, the reason for this, kind of the reason that a Kubernetes native storage solution is really important part of your overall Kubernetes strategy, is that Kubernetes completely flips the narrative in how we do IT operations. In our VMware environments, or even our cloud environments, where really cloud as a business model, meaning, you know, we move to Amazon, we move to Google, but we're still getting virtual machines, we're getting storage, we're getting network. All of the verbs of IT operations, you know, backup, encrypt, snapshot, migrate, were applied to machines, because generally speaking, we would run an application per server. So if we wanted to migrate the application, we could migrate the server. If we wanted to back up the app, we would back up the server. Kubernetes flips things, has us focus on applications instead of infrastructure. And now my application is actually running across multiple hosts, multiple machines. And if I want to back up the app, or if I want to encrypt the application, I actually need to do that across a fleet of servers, where some components are running on one host, other components are running on the other. And, you know, I want to say a different encryption key just for that particular app, even though I have multiple different applications running on the same host. Suddenly I can't encrypt a single host with a single key anymore. I need to be able to provide a level of container granularity. So as you're evaluating kind of how you're going to meet your data management needs within Kubernetes, you need to make sure that you're picking a platform that allows you to really thrive in this application-defined world, not in simply a machine-driven world. And there are 5 kind of key attributes that we look for. And in fact, that drove the Portworx roadmap, although, you know, these are generic concepts that could apply in theory to any Kubernetes native storage. So the next slide shows what these 5 are. The first is container granular. Actually, backing up, let's cut that part. The first is Kubernetes-SCALE, excuse me. So you need to be able to keep up with the scale and the dynamism of a Kubernetes environment. So, you know, a typical, you know, enterprise storage array might have been optimized for a very small number. I shouldn't even say a very small number, a small number of very large volumes, because remember, you know, they're optimizing for SAP and Oracle and SQL Server, which tended to back these monolithic applications. It's like an Oracle database. Whereas with Kubernetes, we're talking about, you know, I've got some Kafka and I got some Elasticsearch and some Postgres and some MongoDB and some, you know, etcd, and I've got dozens of these different data services, and each itself might be, you know, we might be talking, you know, 50 gigabytes, 500 gigabytes, you know, 2 terabyte volumes, but that's nothing compared to these just gigantic volumes that we're serving the Oracle database. And so the pattern is different. I could have hundreds or thousands of these smaller volumes. And then when I do a migration from one cluster to another, I need to recreate them all at once in my new cluster. That type of scale and density is not typically something that we are testing our enterprise arrays for. And so if we try to do it with our Kubernetes environment, we're going to run into problems. The next point is that there's a level of kind of Kubernetes control that we want to see in our environments. So this is things like being able to do migrations at a namespace level, or encrypt a particular tag with a single encryption key. We want to make sure that we can take all of our storage and data management operations using the Kubernetes native language. The next point is an application focus, and we just talked about this, that we want to be able to manage apps, not machines. So I want to be able to pinpoint a particular application. I want to back it up. I want to migrate it, etc. Then there's just kind of a level of completeness that you need to look for. So for instance, if you can only, provision volumes dynamically, but there's no way to back them up or migrate them or encrypt them, then that's a partial solution that you're going to run into problems with later on. And finally, we didn't talk yet much about multi-cloud. Hopefully we can in our Fireside chat, but all of this needs to work in any environment and indeed across environments. So, most of our customers are actually running these hybrid architectures where they're in a public cloud, but they're also on-prem or they're in multiple clouds. And that's a really, really important part of it. So that's kind of my intro. Hopefully we can dig deeper into some of these themes before Chris actually takes it for a whirl and shows us some of the cool things that we can do with a combination of Platform 9 and Portworx.
Awesome, Michael. Thank you for that. I thought we'd start the Fireside chat today, and I like the Fireside in 2 chairs. It's perfect, huh? Right. Mm-hmm. But when I see people adopting Kubernetes and starting out, right, and I think you highlighted this earlier, right, that most organizations aren't just deploying cloud native stateful apps, right? Every enterprise is going to have the need for some kind of storage in a Kubernetes cluster. In my experience, every company needs both. You have any thoughts on that?
Yeah, absolutely. I couldn't agree more, Peter. Thank you. Great question. Yeah, absolutely. In fact, of course, it's in Portworx interest to say everybody should be running, both stateless and stateful apps in Kubernetes. But what do the analysts say? And in the State of DevOps survey recently in the spring from 451, they surveyed their users, and I think it was like 55% of applications on Kubernetes actually had a stateful component, which kind of only makes sense. Like if we compare it to VMware, and say, okay, you can use VMware for everything except your databases. Like we wouldn't have been able to consolidate our data centers because data center consolidation was about all of our applications, not only our so-called apps. We wouldn't have the public cloud because what is Amazon without EBS, without S3, without even their managed data services? The enterprise apps have data, and what we've noticed is that when an organization gets the Kubernetes bug, they realize how much faster they can get to market when they're running apps on Kubernetes versus kind of either a monolithic or even like a kind of a first gen kind of re-architecture, like a SOA based architecture, and then they move to Kubernetes. They move so much faster that the business says, we want more of this, right? I saw that business unit got a new app to market. I want a new app to market too. And they have to apply Kubernetes to bigger and bigger sets of applications. And eventually, right, there's a database in there. And it's just a natural part of the evolution.
Yeah, I think you brought up a good point as well. A lot of people are deploying Kubernetes in the hybrid environment, in their local data center and in the various clouds, AWS and Google and Azure and different things like that. I think this caused them to do different things in different environments, right? Do you think a lot of users find that causing a lot of difficulty when selecting a storage solution, right?
I think it does because the nice thing about Kubernetes is it doesn't matter if it's on-prem or in the cloud. The APIs are the same, and before we got to Kubernetes, containers were all about portability. Portability meant mainly from my laptop to my my production environment. I wanted to develop features on my laptop and resemble my production environment. Well, that portability with containers also extends between environments. So I might be doing test dev in the cloud and production in my own data center or vice versa. And you want that common experience between those environments. But I might be running EMC storage in my data center, but Amazon doesn't have an EMC storage API, right? They have EBS. And so one of the first questions is, well, how do I create a common storage experience regardless of my environment? And that's where solutions like Portworx come in with a 100% software-based solution that can run on any storage hardware and abstract the the hardware specific nature of storage, right? There's always a disk underneath, but abstract that away so that my deployment files, my deployment YAMLs can be the same regardless of, if I'm deploying that in, on my laptop, in a test dev environment in Amazon, or in, on-prem in the cloud. I can do the exact same Kubernetes deployment file. My volume names are the same. Everything's the same. My storage classes are the same. And Portworx does the work underneath to make sure that it is consistently deployed.
Yeah, wouldn't you think just, a default storage class in either one sufficient, or is there a reason to have a Portworx that would say, hey, it's consistent across both my on-prem and my environment? I guess it would come down to the AWS and a VMware or a bare metal environment. I guess it would come down to the choice of how you deploy your Kubernetes cluster at that point, right? Because once you have a default storage class, you can create PVCs kind of on demand. Would that be enough for most of the customers that you're talking to, or is there more benefit to having a Portworx underneath?
Yeah, so I mean, let's kind of define our terms. A default storage class is going to assume some storage. So, for instance, your default storage class, if you're running on Amazon, could be using the Amazon EBS driver for Kubernetes. That would be your default storage class. And for test dev environments, we have lots of customers that start that way, and it's not a problem because it's like your operations are fairly atomic. It's I'm testing a deployment, or I might get creative and test a failover or something like that. But what you're not testing is having a dense environment where, say, you're going to create 50 pods on an EC2 instance when you move into production, because that's the way that you spec'd out your cost for this particular service. It's X number of pods per host. I'm going to densely pack them to get my economies of scale. You're not testing that type of thing. And then, so your default storage class really means your raw EBS service. So you're limited in the capabilities of that underlying service. Now, if you're fine with those capabilities, then there's no reason to look beyond that. Where customers at Portworx have decided to run us on top of what we're calling a default storage class, so say Amazon EBS, is, for instance, it's kind of multifold. Some customers are looking for increased densities, so you can only have, I think it's like 25 EBS, 25 to 40, I forget the exact number, EBS volumes per EC2 host. It's a kind of a Linux networking configuration. Whereas with Portworx, we have customers that are running hundreds of volumes on a single EC2 instance. So there's density, there is cross availability zone, cross AZ availability. So EBS is single AZ, whereas you might want your Kubernetes cluster to be cross AZ. In fact, that's a common deployment pattern to make sure your Kubernetes cluster, your masters, are highly available. And you're not going to have your storage highly available in that model. You might need things like backup and recovery, disaster recovery. There are a number of different kind of enterprise requirements on top of simply having a volume that are important to consider for these kind of true enterprise apps.
Yeah, that's true. If I remember when I deployed my first storage class and had to do something, I used MPD and I got past it. I was real happy with that. But that's a real developer-centric kind of thing. If you could summarize, what would you think are the top 3, 5, whatever you want to talk to, production requirements for container storage within Kubernetes as our prospects and customers are moving into that kind of world?
Yeah, so one is kind of reliability at scale. And the types of customers that we work with, like these apps, it's not a hobby, it's not a side project. There's like real business users and customers behind these apps. So they need to be performant, they need to be reliable, they need to be secure, and they need to be scalable. So you need your storage platform to, if your usage increases by an order of magnitude, that your storage scales along with the scalable compute layer that Kubernetes provides. So that's the first one. I would call that reliability. And again, where people get themselves into trouble is they do functional testing and not scale testing with their Kubernetes. But remember, like if you're not expecting scale and you want to leverage automation, then you shouldn't be using Kubernetes to begin with. So don't assume that like your functional testing at a small scale is a reflection of what is going to happen in production. So that's the first. The second would be data protection, kind of writ large. You need to think about high availability for individual services within, say, a rack or an availability zone in the cloud. You also need to think about offsite backups because Kubernetes clusters, like any other infrastructure, can get blown away, can be subject to ransomware, can be subject to we do an upgrade and it completely breaks everything. We want to just start from scratch. You need to have those offsite backups, and that's not even to mention things like compliance. And then we have some customers that are even looking for like true multi-site disaster recovery, where so one example would be Royal Bank of Canada. We recently did a webinar with them, so folks can find out more directly from there. But they needed complete failover between two independent data centers with zero RPO, zero data loss, and very, very low recovery time objectives or RTOs. So kind of data protection writ large, and importantly, available on an app by app basis. So, any storage provider is going to say, oh, we do all three of those things, which is absolutely true. But can they do it for what this Kubernetes application versus this one, where they each have their own view of how to implement those and the requirements of them? Multi-site DR can be expensive because you need a second cluster, a second infrastructure. So you want to do that for the apps that really require it and not have apps that don't need it. So you want to be able to provide these things on an app by app basis.
Right.
The third thing would be just mobility. Make sure that you can move your applications to the environments that are most relevant for them. So which means you can move apps and data together between environments.
Right. When I was starting with Kubernetes and doing things, I created PVCs and I used them, and I found it difficult to expand or scale. At some point, I think all of our users are going to want to expand storage for a given pod, right? And I remember previous versions of Kubernetes, you couldn't even do that, right? And I forget which version it flipped, but you can do it now. But in an enterprise scenario, how are your customers thinking about doing that and expanding that environment?
Yeah, it's a great question. So, you kind of, even if you're trying to apply Kubernetes to your biggest business problems, you still start small. So expanding, kind of scaling storage is one of the tricky problems in computer science, which is why we kind of punted it as long as we could, but now, hey, we have to solve it. We've approached it kind of using the operator pattern. That's a little bit of a kind of a buzzy phrase, but basically what it means is that we kind of embed operator knowledge about how to scale particular databases and storage systems into Portworx itself, using something we call PX Autopilot, which does what it sounds, right? It's your autopilot for Portworx. So if we notice that you're approaching 80% of your storage capacity, then based on rules that you can set and you can modify, we can provision additional storage capacity. And in the cloud, that actually means provisioning new EBS volumes. You don't even have to like bootstrap and add an EBS volume to your cluster manually. We can do that for you. Same thing in a VMware environment. And so that model of understanding what storage is available, how individual volumes are being consumed, and is it one volume that's almost out of capacity, or is it my physical storage layer that's out of capacity? We can scale those two different objects independently and enable kind of really tight tolerances around over provisioning, which is one of the ways that when Portworx is running on the cloud with autopilot, we can see our customers saving 50% or more on their storage because they're not having to provision for peak. They can provision for the average, with Portworx helping them scale when they get spikes.
That's excellent. Yeah. So I think one more question on the Fireside chat before we get ready to turn it over on the demo. But I think it's an important one. Security. I think everybody at some point will find that their pods need access to sensitive data, right? Yeah. There are ways of doing it with Kubernetes, role-based access control, and all of that. Does Portworx offer something simpler to help manage that sensitive data?
Yeah, absolutely. So we have a number of different solutions for that. So just to kind of run through them quickly, encryption, kind of container granular, app granular encryption, where the customer controls the keys. So you can do things like, encrypt a particular volume or, a set of volumes associated with an app. So based on a tag or based on a namespace with the same key. And then if you take a snapshot of that and then you put it into S3 or wherever backup and then you restore it, you're going to be able to restore it with that same key. The data remains encrypted through the entire application lifecycle. We also enable role-based access controls down to the data layer. So Kubernetes itself offers an RBAC model, but that's for your Kubernetes objects, which is a little bit of a subtle distinction because a PV is a Kubernetes object, but that's really just a pointer to the data itself. The data itself falls outside of Kubernetes control, right? Because that's actually in your storage infrastructure. But you don't want to, deny access to a Kubernetes object, but then enable someone with access on that server to access the actual data. And yet that's kind of how things work in Kubernetes. So we bring the role-based access control for the underlying data to marry the RBAC that's available more broadly within Kubernetes.
Awesome. All right. I think we should move on a little bit. This has been a great conversation. Thank you. I just wanted to touch on, and Chris, I'll hand it over to you after this slide, the Platform 9 solution, right? We spent some time talking about Portworx. Platform 9 does offer a managed service around Kubernetes, right? We can deploy on VMware and OpenStack VMs. We can deploy on bare metal. We have customers deploying Kubernetes clusters in retail edge spaces around the globe. We're working with 5G. We've done some previous stuff there. We can deploy Kubernetes clusters in the public clouds, right? And we come with those simple decisions, right? If you want an on-prem load balancer similar to what AWS provides, we can do that with NetLLB. We have observability with FluentD and Prometheus and Alert Manager and Grafana. It's a quick box to deploy, right? We've got some network plugins around Multis, OVS, Flannel, Calico, SRIOV, DPDK, and different things like that if you want to do line speed access directly into your Kubernetes pods. We've got app catalogs, right? We've got a public repo called Cool Kubernetes that allows you to, get tutorials. How do I do a CI/CD pipeline? And these all work with the Platform 9 free tier. So if you wanted to go try Kubernetes out, I encourage you to go to platform9.com and sign up for our free tier. Go to our Cool Kubernetes public repo and try some stuff. There's some storage stuff in there. There's some CI/CD stuff in there, ingress controllers, service meshes, all kinds of different stuff for you to play with. So I encourage our customers to take a look at that. So, all right, my 1 minute commercial on Platform 9 is over, and I will pass it over to Chris Jones. Chris, I'll let you share at this point.
Sure. Thank you, guys. That was a very interesting discussion. I was following along in the background. I am going to step through some slides super quick. As was being touched on, setting up a cluster is a fun adventure, and then connecting storage, which is really required to make things function correctly, especially if you're using Helm to deploy apps, is a critical next step. So what I've got set up in this demo environment is Portworx and Platform 9. I built 2 clusters, each with 4 nodes. They're a single master setup using what we call BearOS, which is just running on top of CentOS or Ubuntu, and they're VMs in the Platform 9 managed OpenStack environment that we use internally. You can see the rest of the nodes set up there. I'm not going to delve on that too much, but I am going to call out that you want volumes attached to your node, but you don't want them mounted as a file system. That's what Portworx is going to take advantage of to then build out your provision storage if you're in the virtual machine world. So that is an important requirement there if you're going to give Portworx a go. And there's a free platform of Portworx that I'm also leveraging, and I'll touch on that very quickly as well. As part of this demo, because I'm going to touch on some of the backup and restore capabilities, I've enabled the Portworx backup, PX backup. I don't have a load balancer in my environment, so I decided to make a quick modification to NodePort there. I also deployed WordPress, which deploys databases in the back end that are then running off of the persistent storage provided by Portworx. And last but not least, to make PX backup work, you can choose Google, Azure, AWS. I opted actually to deploy Minio S3 storage into the cluster myself. All this data that I'm sure you're looking at and saying, well, this is a lot of information, we will be making available on our blog afterwards, so you can follow along if you want a sort of an end-to-end solution to test for yourselves. But I used Minio for S3 storage, and as you can see there, I provided a secret key and an access key, which is kind of critical to get things running. Always good. Made a list of where everything is running and how to get to it. So I'm going to jump right in to a live demo here. As Peter touched on, if you want to get a cluster up and running, come to platform9.com, put your email in, and then choose where you want to deploy. Choosing where you want to deploy is important because we'll send you some helpful information that's really targeted towards each of those services. So once you've signed up, you will land on a dashboard interface that looks something like this. From here, what you want to do is come to infrastructure and click add cluster and choose where you would like to deploy. Once that's done, you need to head over to Portworx, sign up, and once you've signed up for their free service, you're actually going to land in the Portworx dashboard. On first touch, you're not actually going to see this screen. This is a list of specifications for your Portworx installations. You're actually going to land on a Portworx start page like this. This is a wizard that will help you get going. I've actually used the Portworx Enterprise trial and set up a spec, which I'm not going to go through today. And I've done the same thing for PX for the backup as well. All of these basically create you a specification that you can go through to then deploy Portworx as well as PX backup into your application. So I use the Portworx operator. I followed each step, answered all the questions. Most of my setup is purely just for a proof of concept / trial. So I've made a number of decisions like building an etcd as well as excluding a dedicated journal volume for tracking access to the storage. So depending on what you're looking at doing, there's either a really quick way or a really easy way. I've taken the easy path. Once you go through all of these configurations, as you can see, I've done auto and made some pretty simple changes there. It's very easy to get going from that point onwards. When you click finish, agree to the license terms, literally copy and paste 2 commands into my cluster. Once that is done, you'll be able to see a number of different services running within Cube system as well. So you'll see I've got 2 PX labeled services that are running here. One is an operator, one is the CSI. To check if it's running, very simple to do, just a kubectl, cube system, get storage nodes, name Portworx, and you'll see the status of your Portworx cluster running within Kubernetes. The next step from there is the all-important storage class that was discussed in some detail here. Very easy to miss this step. When you come to storage classes, you'll notice that there are a number of storage classes running. I have deployed Portworx across two clusters in this environment. So just to focus this on cluster 1, you'll see there's a number of storage classes already defined. What you'll need to do is come in and define a default storage class. This can make it much easier when deploying apps, so you don't have to specify a storage class. This was touched on. I've called mine works default. I did actually mark it as a external storage class. And the provisioner I've used, important to note here, is the CSI provisioner as well. So once that's done, I went through the process of saying, well, let's get an app running. First app I went to deploy was PX Backup. That was done all via Helm. And I now have this running on the cluster right now. So once you deploy PX backup, you just have to come in and click add cluster, provide the cluster name as well as the kube config. This was super easy. I connected it to my Bare OS on-premises clusters and it connected instantaneously. As you can see, I've actually got 4 clusters. I run quite a few internally for testing purposes. And you can see Portworx 1 here. So that was really easy to get going. The next step was S3 storage. As I said, I used Minio, I used Helm to deploy that as well. Minio is running here. I am downloaded the values.yaml file for Minio to make it slightly easier to set it up using Helm. The modifications I made to that were touched on those opening slides, but I provided a secret key and access key. Minio will generate those if you want them to. I also changed it to use a NodePort just to make it easy to get to for demonstration purposes. What you can see on the screen here today is a series of backups that have been created from PX backup. So to add that, after you've added a cluster, it's very easy to come in and say cloud settings, add a cloud account by clicking add, and then adding a backup location. One of the things that I personally sort of stared at for a little bit, I was like, I wonder how this is going to work, was how to put Minio in here. So I sort of just did the best guess. Put it in here. First time around, I actually provided the cluster IP, which obviously is only available internal to the cluster. After doing some tests and backup and restore, that worked fine. I wanted cross-cluster capabilities. So I put in the NodePort, and that's been working completely fine. Obviously, if you had a load balancer, it would be much more resilient and stable to provide a load balancer IP externally. So that's kind of the PX backup setup. From that point onwards, it's actually pretty simple. So drill into your cluster and choose a namespace that you would like to back up. In this case, I have WordPress as well as Guestbook running. If I select WordPress, oops, I'm on the wrong cluster. This will load. This is actually a restored WordPress deployment from my second cluster. So that's a restored app. If I go to Portworx cluster 2 that I've got running, click on backups, I can see that I've got a WordPress backup here. It was 109 meg. This was really easy to do, right? Select the app, wait for it to load. You can filter what it is you want to back up. Not complicated. By type, I just clicked backup, provided the name, selected the backup location, and click go. As simple as that. And off it goes. This obviously can give you a state here. You can see you can have one that's failed. If you want to see information there, click show details. And it's going to say here, Chris, you provided the cluster port and IP. Obviously, that's on cluster 1, and this is on cluster 2, so that failed. Here we can see information about the successful backup that's running. Once that's done, you might be thinking, I want to test a restore. So I can show restores here. Guestbook cluster 2, restored from backup cluster 1. So that was a restore that I did from this particular cluster back into itself. If I go to cluster 2, go to restores, we can see Guestbook Minio external. So this is restoring from the storage running on the first cluster to the storage in the second cluster. For demonstration purposes, if people want to see the Guestbook app, this is an IP address and port running on my cluster here on a VPN. I can interact with this, click submit, that data is there. This is the Guestbook application that was restored from a backup. So I did nothing else than back it up, click restore, and all of a sudden I've got a second application running that I can interact with on my second cluster. Same thing with WordPress. This WordPress site is running on my first cluster, and I was able to back that up, restore it to that cluster very simply and easily with the storage all available, and moving it to the second cluster as well, exactly the same thing, provisioning the entire application as well as the storage across to that as well. So that's a pretty, I guess, short and sweet demonstration of, a little bit of Platform 9 and a whole bunch of Portworx storage running in the back end, supporting, PX backup, which in turn was using storage running on an S3 provider that's running on top of Portworx as well. This took me a couple of hours to get going, a little bit of learning along the way. Good documentation that's out there. So if people are looking to get going, the doc sites of both Platform 9 and Portworx will help. Good, webinars access like this, as well as some blogs will really help you get going and get persistent storage running in your cluster, as well as, start learning about backup and data protection, which is going to be critical for running your production applications.
Hey, Chris, we're getting some questions. I think we're at the Q&A stage. Are you kind of wrapped up with your demo?
I am completely wrapped.
Okay,
what I would like to say is when people log in, you're probably going to see our current user interface. We do have a rather large release that's coming out with multi-version support and some other significant enhancements coming out in the next 2 weeks. So stay tuned. Before Christmas, if you sign up, you'll get the old interface. If you sign up in 2 weeks' time, or if you're a running customer, you'll be upgraded to this new user experience, which is full of a bunch of new features like multi-version, and it's definitely something worth staying around for and trying out as well.
Terrific. Thank you, Chris. There are a bunch of questions coming in. I guess the first question is related to benchmarking. I guess this is for you, Michael. I guess it's a question about performance benchmarking of Portworx storage compared to other CSIs. Do you have any data that you could share?
Yes. So sorry, my video back on. Yeah, so on our documentation, we have some benchmarks. And then if you want to kind of see some third party, if you just Google, what would you Google? Like Portworx, storage, performance, let's see what happens. There were a couple of independent bloggers that recently, if you Google Kubernetes storage performance comparison, you will find an independent party who just kind of pulled a bunch of Kubernetes storage solutions and compared them, and that'll give you a baseline.
Terrific. Another question came in. We were talking a lot about backup, restore, HA, migration. So this is an interesting question. We all know that there was an AWS outage, a big outage a couple of weeks ago.
Yeah.
The question is around, would Platform 9 and Portworx together enable or at least prevent an outage like that in AWS, as long as you have some sort of a backup location set up?
Yeah, I mean, that's the goal. I don't want to over, but basically, if you look at what happened in that outage, it was relegated to a single region, basically with a combination of PXDR and Platform 9. PXDR is our disaster recovery solution. You can actually have a live standby of your application. So in this scenario, let's take like the most stringent requirements, 0 RPO, failover in a case of a catastrophic outage like this. Portworx can actually synchronously replicate data to another region, as well as all of your Kubernetes objects and application configuration, and enable you to fail over at kind of the load balancer level. Once you detect that one site is down, you can simply fail over to another site. This is actually what we've implemented. I think I mentioned Royal Bank of Canada earlier in my comments. This is what we've implemented for them. So yes, it's totally doable, and I think demonstrates the promise of Kubernetes and solutions like Platform 9 as kind of a framework that you can run on top of any infrastructure to enable that global availability.
Terrific. We're almost out of time, but there's one interesting question here about existing storage, right? I think you probably covered this during your discussion earlier, but if I already have an existing block store device and I have data in there, how do I now migrate that or plug that into Portworx Platform 9 solution?
That is a great question, and it kind of depends a little bit. So at this level, I would say, basically we have migration tools. So if you've already got it, and it's different if the app's already running on Kubernetes versus if it's not running on Kubernetes. So the kind of the details are a little bit different, but suffice it to say, we have tools to help you migrate the data to import it basically into a Portworx volume. And then from there, you get all of the Kubernetes native capabilities.
That's fantastic. Thank you, Michael. I think we're at the top of the hour, and we should be wrapping up our webinar, but not before we announce our winner for today's drawing. So it's the name is Aditya Radha from AppDynamics. He's an SRE there, and congratulations, Aditya. I don't see you here live, but you should expect to see the free course show up in your email shortly. Thank you, Michael. Thank you, Peter and Chris. It was a great webinar, very informative. We will follow up with a post-webinar video for those of you who missed the webinar and if you want to recap any of the stuff. So thank you again, and appreciate you joining us, and look forward to seeing you in the next webinar. Thank you, everyone.
My pleasure. Thank you.
Have a great day. Bye-bye.
Thanks, everyone.